In this question, we have small trigonometric problem here. So from the top of a building that overlooks an ocean, an observer watches a boat sailing directly toward the building. If this observer is 100 feet above the sea level, and if the angle of depression here is the angle between the horizontal and the line of sight, looking down of the boat, and it changes from 20 degrees to 45 degrees during the period of observation. So they want you to find the distance the boat traveled toward the building during that period based on that information. So this is a classic trigonometry elementary. So if we look at the sketch here, this is how it looks like. So the observer is on top of the building there, and when the boat is at the initial position, the angle is 20 degrees, and at the second position 45 degrees. So the distance in red here is the distance the boat traveled between these two positions. Okay, and to find this distance, we are going to use trigonometry. So we have two triangles here, the big guy here. So if you see the boat, the base of the building and the top of the building, so from the initial position to the bottom of the building, we call it D1. And from the second position to the bottom of the building, we call it D2. So the distance traveled D is equal to D1 minus D2. Okay. So we are going to reduce this one and do the calculations and find out what D is. If you look here, we have alternate interior angles because these two horizontals are parallel, and you have the transversal. So 20 degrees there will be 20 degrees down here at the initial position. And the same way for the 45 degrees at the final position, you have 45 degrees there and here because of alternate interior angles, these two parallel horizontals. And the transversal cutting them. So we reduce the sketch here to get some room for calculation. So we are going to see how we find D1 and D2, and from then we deduct the value of D. So for D1, on the big triangle from the top of the building to the initial position of the boat to the base of the building, we have a right triangle, and we have 20 degrees here. So we can say tangent of 20 degrees is the opposite side, which is the vertical part of the building, 100 feet over D1. Okay, and we can say, all right, 100 over adjacent. And the same way we can find for 45 degrees, we can say that tan 45 degrees is equal to 100 over D2. We can deduct actually D2 is already 100, which we look at, because 45 degrees there, so that's good. Okay, now we can say D is equal to D1 minus D2 is equal to 100 over tangent 20 degrees minus 100 over tangent 45 degrees. It is 100 times cotangent 20 degrees minus, we know that tangent 45 degrees is 1. If you look at the sketch, that meant to say that d2 is also equal to 100 actually, without calculation. But since we are interested in d, we say d1 minus 100 there. So if we do the calculation, we use our calculator here. 100 times cotangent 20 degrees minus 1 that should give us our result. We have 175 feet approximately, so they ask that to approximate that. So that is the result. So we can safely say now that the distance d is roughly equal to 175 feet. So that was the question, and I hope you understand this basic trigonometric problems, and we will solve more detailed problems in the future. Thank you.